Here's a lesson on explaining why something is or is not a function. So we have three different situations. We have graphs, tables, and mappings. We have two of each. And you might imagine that there's one of each. One of each is a function and one is not. So it's really about using the appropriate reasoning for each situation. So let's start with the graph. Go with the red graph. And what you should be doing with any graph to see if it's a function or not is do the vertical line test. Okay, so this red graph seems like it passes the vertical line test. So we would say that yes, it is a function. Why? Is it passes the vertical line test. When we move to the blue graph, again, graphs, we're going to use the vertical line test. And you can see that it fails everywhere. Well, actually, beyond this point, you can see that it would only have, like this arrow here, were to continue outward, it would only hit in that one spot, or past here, it would only hit in one spot. But between, right around, if this was x is 1 and x is -1 or so, it would fail miserably. It would fail all over the place there. So this one is not a function. And why? It fails the vertical line test. And I'm certainly looking to shorten up some stuff here. VLT is fine with me. These other ones are a little less obvious. I think the visual is a lot easier for people. So what happens here when we're looking at a table of values? Okay, and it really comes down to understanding. So for every input, there's exactly one output. So here are my inputs. So I'm literally going to check how many outputs does the number 4 have. Just has 1. 5 has 1. It's 2. 6. How many outputs does 6 have? It only shows up, each of these inputs only shows up exactly once, and it corresponds with exactly one output. Now, a lot of people see this and say, oh, there's a duplicating output. It doesn't matter. We're looking to see if there are multiple inputs of the same number giving us different y values, okay? So I would say that this is yes, it is a function. And my reason is each input has exactly one output. Here, 1 occurs once, the output is 5. 2 occurs twice with different outputs, okay? 2 has, I should really say, an input of 2 has 2 outputs, not a function. Okay, again, this input, okay, so I'm looking through the inputs and I see that 2 occurs twice. That's a red flag for me. And when I see that those two outputs are different numbers, then I know it's not a function. If this 6 were a 5, then both of the 2's would give me 5, and that would still be okay. Here's one where all of the inputs have the same output. All of the inputs have the same output. So here, how many outputs does each of these have? Or how many arrows are coming off of each of the inputs? Each of the inputs has exactly one arrow coming out of it. Each of those arrows represents an output for that input. So this is a function. Each input has one output. Now, a lot of people prefer seeing the visual. In any of these situations, you could show it on a graph. Okay, so this one's a little tough because we're looking at 99. So all I'm going to do here is change my scale, call this 100. Here's 1, 2, and 3. And just below 100 at 99, I'm exaggerating a little bit. Okay, just below 100, I have my 3 values. So the points are represented, each arrow is 1 point. So that first arrow is here, 2, 99 is here, 3, 99 is there. And when I look at this using a vertical line test, it would pass. So if you prefer and you wanted to graph each scenario, I think it's a little slower, you could graph it and then use the vertical line test as justification. But without the graph, we can't use the vertical line test. Here, this is not a function, and the reason is the number -2, or the input -2 has outputs of 20 and 30. So it has 2 different outputs. So you need to justify each situation appropriately.